This is Dr. Ahmed Al-Samari. Our lecture today is about HVAC or air conditioning. It's an introduction to air conditioning concept. What does mean air conditioning? Why we need air conditioning? Actually, in our modern life, air conditioning it's very important. Actually, we cannot live without air conditioning. With this type of building, no way you may live without air conditioning, especially in the environments or climate that is very cold or very hot. In the climate that is mild, it's not hot or cold, about 70 degree Fahrenheit, it's maybe capable of living without using AC or air conditioning systems. However, these climates are very rare now. All our environments are even very hot or very cold. So this introduction is about the concept of air conditioning. I will start with the definition and then explain how to use these concepts to build knowledge regarding air conditioning. The definition says air conditioning systems usually provide year-round control of several air conditions, namely temperature, humidity, cleanness, and air motion. So we have for air conditioning applications to control temperature and humidity, moreover or also purity and air motion. These systems called HVAC stand for heating, ventilating, and air conditioning. Around the world, in US, in Europe, all other countries or most of other countries called AC systems or air conditioning systems by HVAC systems. And it is a stand for heating, ventilating, and air conditioning. Heating, ventilating, and air conditioning. Moreover, this science or textbooks for this science issued by Ashri. Ashri is very important source for the science of HVAC. Actually, it can be the standard for this type of science. Ashri is a stand for American Society for Heating, Refrigeration, Air Conditioning Engineers. American Society for Heating, Refrigeration, and Air Conditioning Engineers. The textbook we are going to consider for this study is Principles of Heating, Ventilating, and Air Conditioning, 7th edition by Williams Code and Harry Sauer, Ronald Howell, issued by Ashley. First lecture will, as I mentioned earlier, this will be definition and introduction for HVAC. First of all, control thing you have to know about it. So we need to control air, to control temperature, to control humidity. So we need to study it to know about the air. We all know that air consists of several gases such as nitrogen, oxygen, monoxide, carbon, dioxide, carbon, and so on. However, there is another part can be added to the air components. It's called water vapor. Water vapor, it's one of the air portion. May someone wondering about what the source of this water vapor? In fact, the major source for the water vapor is the human itself. In the breathing, we discharge a lot of water vapor with the air. Moreover, trees and plants are other source for water vapor. Seas and rivers and all other type of water gathering are source for, could be a source for water vapor. So water vapor, if it is increased in the space, or in any application, it will make you feel uncomfy. You need to remove it. So I have to study it, how to analyze it, and then how to control it. Sometimes I need to add it. Sometimes I need to remove it, depending on the applications. So human comfort design conditions are quite different from conditions required in textile mills or for grain storage, and vary with factors such as time of year and activity and clothing levels of the occupant. If improperly sized equipment or the wrong type of equipment is used, the desired environment condition usually will not be met. Furthermore, improperly selected and or sized equipment normally requires excess power and or energy and may have a higher initial cost. So to design or to know the proper type of air conditioner for your application, it's very important. Therefore, this is the first step in our study to know about the air conditioning, which is learning about moist air. Now we agreed that the air consists of dry air, which includes oxygen, nitrogen, dioxide, carbon, monoxide carbon, and all so on, and including water vapor. Mixing of these water vapor and dry air is called moist air. Okay. Now the term called mixture or mixtures is a large number of thermodynamic problems involve mixtures of different pure substances. A pure substance is a substance which is homogeneous and unchanging in chemical composition. By the way, anyone like to get this lectures, I can upload it for him or send it for him, and she will be more than welcome to ask regarding that. And the reference for these lectures note are this book, as I mentioned earlier. This book, textbook, is the reference for all my lectures. Okay, mixture. Since individual gases can often be approximate as ideal gases, the study of mixture of ideal gases and their properties is of considerable importance. Each constituent gas in a mixture has its own pressure called the partial pressure. I will explain it in details and in direct way. The summary of Gibbs-Dalton law says the pressure of materials consists this gas or this fluid is equal summation of them. The pressure of mixture equal summation. In other words, the pressure of atmosphere is equal the pressure of dry air plus the pressure of water vapor. For example, the atmospheric pressure at sea level is about 101 or 1.325 kilopascal, or sometimes we just say it's 1 bar or 100 kilopascal. So for example, the pressure approximately is 1 or 1.5 kilopascal for water vapor pressure, and the rest is for the dry air is about 98 or 90, depends on the summation of them will be 100 kilopascal. Is part of the total vapor for the mixture according to this equation. However, the volume is constant, which means if we consider, for example, a space about 70 cubic meter, okay, 70 water vapor inside this space, volume will be 70 cubic meter. The dry air volume inside this space will be also 70 cubic meter. I hope this it's clear for you. So this is the main principle of partial pressure law or Gibbs-Dalton law, and you should be familiar with this law. I think it's in the second stage in the course of thermodynamics. Is the principles of it. Use Gibbs-Dalton and understand it. If anyone didn't understand what I said, I can repeat it for him with pleasure. Another Magnett's law, it's assumed mixture. However, the volume is additive, which means PM equal PA equal PC equal PD, but VM equal VA زائد plus VB plus. In fact, we will not consider this law in our study. I mean, through the next lectures, we will consider the Dalton law about the partial pressure relationship per mixture. More often, temperature for mixture equal temperature for A, temperature for B equal temperature for C. But the mass of mixture or total mass equal summation, which makes sense. I mean, mass for mixture equal mass for dry air plus mass for water vapor. So these concepts are very important to make you able to understand the next part of this lecture, which is cyclomatics or moist air properties. I will stop here. Just as an introduction, I will repeat it. HVAC is what can be defined. Systems usually provide year-round control of several air conditions, namely temperature, humidity, cleanliness, and air motion. So, to control something, you have to know about it, and that the moist air consists of dry air and water vapor. We know about the mixture of dry air and water vapor rules. I mean, the mixtures mean that total pressure equals summation, the volume equal constant, temperature equal constant for each component, mass for mixture equal summation, Ma plus Mb plus Mc. I hope I gave you a good introduction, and next lecture will be about the moist air properties and what are these properties, how to calculate them using several methods. I will explain several methods to calculate moist air properties. I am recommending you to subscribe this channel to get more videos more clips or more videos, more recording regarding this types of science, HVAC, and other details. Have a good time, and thank you for listening.